Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
All right. So in this problem, so uh, we have a block on the frictionless horizontal plane, and so for the part for the first two parts, we have a force exerting to this direction, and the theta, here's the angle theta, and we know the magnitude of the force equal to 2 newtons, and also we know that the block has a displacement d equal to 1 meter. So for part A, if initially the block is not moving or the initial velocity is 0, we want to find out the final velocity. So we just use the work exerted by this external force, which is F times, we just need to consider the horizontal component, times cosine theta times the displacement equal to half mvf squared. Okay, so vf is the final speed. So we can find out the final velocity vf simply equal to right, the mass of the block is 4 kilograms. Just plug in the values. See the final value is square root cosine theta. Okay, and for part B, so suppose the initial velocity of the block is 1 meter per second. We want to find out the final velocity in the same condition. So just use half mvi squared. This is the initial kinetic energy plus the work done by the external force, which is F cosine theta d equal half mvf squared, right? So this is the work. This is the energy conservation law, and you can actually solve for vf equal square root 1 plus cosine theta. And part C is suppose we also have this block and on the frictionless horizontal plane, but in this case, the force is pointing to this direction. So this is theta, and there is initial velocity of 1 meter per second pointing to the right. So again, we want to find out the final velocity. So just use the same rule, half mvi squared. This is initial kinetic energy, uh, minus in this case f times cosine theta times c. That's because the horizontal component of the force is actually opposite to the displacement. So this is a minus equal half mvf squared. Okay, so you can solve for vf equal to square root 1 minus cosine theta. All right. So this plot actually shows the three solutions by varying the different angle theta from 0 to 90 degrees. So this is for the uppermost curve is for part B. This is for part A, and the last one is for part C. Okay, and you can actually see that for the part A case, when theta is 0, it means that the force is actually horizontal and pointing to the right, and in initial velocity is 0. So the final speed, the final velocity is simply equal to 1. But if the external force is pointing down or theta equal to 90 degrees, then there is no the combined force on this block is actually 0. So the force is equal to 0 in this case. Not the force, the final speed. So for part B, it's similar. If theta equal to 0, then the final speed is larger than the initial speed. So the final speed is 1.4 meter per second, and the initial one is 1 meter per second. But if theta equals 90 degrees, that is the external force is pointing down, and the combined force on the block is 0, then the speed does not change. So just a constant equal to 1. And for part C, it's similar. If theta equal to 0, then it is pointing to the left. Then this is a decelerating process. So you'll see that uh, if theta equal to 0, then the final speed equal to 0. But if theta equal to 90 degrees, so in this case just pointing down, then the combined force on this block is 0. So the speed does not change and just remains at 1 meter per second. So that is the physical interpretation of the three solutions.